5.2, the title is More Exponents, because that's all it does. It teaches you one last rule. It teaches you the rule that if you have anything raised to a power, and you're raising that to a power, this is when you multiply the exponents. So I go n times m. So if I gave you x squared raised to the 8th power, that is when you go x is raised to 2 times 8, or 16. If I gave you 3, a number instead of a variable, let's do 3 to the 3rd squared. Well, once again, I just multiply the exponents. Don't change the base. You didn't change x, you don't change 3. And it is 6. Let's deal with a negative exponent for a second. What if you see something like this? Well, just like the rule says, you still just multiply exponents, and a negative times a positive is negative. But now you have to go one more step and make that exponent, positive. That should say x. X to the positive 35th. Ugh, that looks bad. Alright. Now what they'll do is they'll combine all your rules together here. So, for example, you could, and let's do this first. Let's say I give you 4n to the 3rd over n squared, and we're raising that whole thing to the 3rd. The reason I want to show you this one is that that exponent raises everything in parentheses, just like you have 4 to the 3rd, which is 4 times 4 times 4, which is 64. So numbers don't change your rules. They're still 64. But the exponents we multiply. So I have m to the 3rd raised to the 3rd becomes, and n, this is raising the bottom too, isn't it? So to the 2nd raised to the 3rd becomes n to the 6th. Okay. So this is starting to look like a possible test question. Let's see. What if they gave you this one? 7xy to the negative 2 raised to the negative 2. So now we know we're raising every single thing in the parentheses, and there's two ways you can do this. You could begin by making it positive, by putting the whole thing on the bottom. And look, nothing inside changes. Only the outside became positive 2 when you do that. And then you raise everything to the positive 2. So remember that coefficients are just 7 squared. 7 squared we know is 49. But exponents you multiply. And there's nothing on the x, so it's like a 1. 1 times 2. So I have x to the 2nd. And then I have y, negative 2 times positive 2 is negative 4. And we know we can't leave a negative exponent, so I'm going to move that to the top and make it positive. But the 49 and the x squared stay in the bottom. Now if you chose to, you could begin by raising them all to the negative power. So the other way to go would go, I have 7 now to the negative positive 4. And then I go, well, I can't do the negative exponents, so I'll put those on the bottom, but I'll leave the y to the 4th on the top. So now those become positive because I've moved them to the bottom, and then I can go ahead and do 7 squared, and so I get the same answer. And once again, if you're not sure which route to take, do it both ways, and you should see that they equal the same thing. Okay. What about this one? 6 to the negative 2 times x to the negative 4 times y to the 10th all over x to the positive 2 times y to the negative 6. So again, lots of routes. You could do that, or you could start by the division, which means you would subtract. So we can do it both ways. So let's say I need to move x to the 4th to the bottom. But I've already got x squared on the bottom, and it's positive. Now my 4 comes down there too. My y to the 10 stays on top because it's positive, and this one is negative, so it moves to the top. So making everything positive first, now doing it, I know when I'm multiplying the base, I add the exponents. So you should have y to the 16. Right here, I treat coefficients like always. 6 squared is 6 times 6. which is 36. The base is the same, so I can add the exponents. So I add 2 plus 4, and I get 6. Or, of course, the other option is that instead of making them positive to begin with, I could actually do the division first. So if I did that, I would go x to the negative 4, subtract 2, right? Because you subtract when you divide. Same with the y's. I would have y subtract negative 6. Alright, so then going further, I go, well, I can't do 6 to the negative 2 on top, so I'll move it to the bottom, so it's 6 to the positive 2. And then negative 4 and negative 2 is negative 6, and 10 subtract negative 6 is 10 plus 6, so I have y to the 16. But I have to go another step, so I'm going to leave my 16, my y to the 16. I'm going to go ahead and do 6 squared, which is 36, and then I'm going to move this negative exponent to the bottom and make it positive 6. And you can see that, oh, we got the same answer, so we know we're right. And so it's a really good option if you're not sure to try both ways. Alright, I just have 2 more problems. These are kind of big. They absolutely look just like you could see on a test, so I like them. For example, I have a great big parentheses with 4a to the third b squared all over b to the negative 6 c. And all of that is raised to negative 2. Now, here again, there's a couple routes we can take. I could begin by making this 2 positive. And if I do that, I'm going to move everything from the bottom. So I don't change anything inside. This b to the negative 6 stays negative 6 because I can't change this and this in the same step. So I'm changing this, so all of these stay the same and they just move to the top. These stay exactly the same to the top, and now this becomes positive. So now I can raise everything in the parentheses, and we know when we raise to a power we multiply. So negative 6 times 2 is negative 12. 1 times 2 is 2, won't it? And a to the third, 3 times 2 is 6, and 2 times 2 is 4. Now I need to go one more step. I need to combine like bases. I don't want b in there twice. And I can see that if I move this to the bottom, it will be positive. So I'm going to do that. So I'm going to leave the 4. I'll write 16 instead of 4 squared. I'm going to leave the a, but now what I have is b to the 4 and b to the 12 because it's positive now, isn't it, on the bottom. And so lastly, I need to combine. When I multiply bases, I add exponents. So I have 16, a to the 6th, b to the 16. Now that was making this positive first. What I might want to do is simplify the inside first and then raise to the power. So if I simplify the inside first, I would go, oh, 2 subtract negative 6. So I would have a to the 3, and then I would have 2 subtract negative 6 because I have the same base, so I'm subtracting exponents. Which is, and then I'll just go ahead and leave my c on the bottom. And this is still all raised to the negative 2. We haven't done anything with that yet. But now I'll go ahead and just do this one step right there. So I have a to the 3, and then I have 2 plus 6. So it's 8, isn't it? All over c. And now I'm still raising to the negative 2. If you wanted, you could flip it right now. Or let's go ahead and do it a different way. Let's raise everything to the negative 2. So I have 4 to the negative 2. I have 3 times negative 2, which is negative 6. I have 8 times negative 2, which is negative 16. And I have c to the negative 2. And then I have to go another step and make all of those positive. So now I end up flipping it at the end. So you could flip it at the beginning and make it positive, or you can distribute it and then we flip it at the end. and that becomes 4 to the positive 2, a to the positive 6, and b to the positive 16. And of course, we would have to go one more step and do 4 squared. And so our final answer is the same as we got before. So that's good. We know that we're right. Alright, let's do this one. And that is a lot like a final exam question. So it's an important one that you want. When you see ones like that on your homework, ask for multiple problems and do it over and over. Make sure you're good at it. Alright, how about this one? This one's kind of mean, I think, if I remember right. Alright, so let's go ahead and raise this one to the third. X to the 9th, 3 to the third, and y to the negative 3, right? Negative 1 to that 3, so that's nice. Now here, should we go ahead and just take care of the negative 1? So I'm going to raise everything to the negative power. So negative 2 times negative 1 becomes positive 2. Oops, this isn't equals, this is times. Because this is this times this. And I just did the first one. So it's this times. I've got now y to the positive 2 all over 3 to the negative 1. And x, negative 1 times negative 1 is positive 1. Combine anything with the same base. Since I've taken care of the exponents, now if they have the same base, I can combine them. So let's go ahead and do that step. So I still have my 4 to the third and my 3 to the third, which they might make us do, but they might leave them like that. When they get big, sometimes they're kind of nice and they just leave them. But, oh wait, they will okay. I have 3 to the third and 3 to the negative 1. So that's, I'm going to go 3 plus that negative 1. So I will have 4 to the third on top, but I will have 3 squared on the bottom, won't I? When I add 3 and negative 1. Okay, so now I've got my x to the 9th and my y squared. And down the bottom, I have y to the negative 3 and x. And so here, I have the same base, so I need to combine those. So I've got 4 to, let's write it down here. I've got 4 to the 3 and 3 squared. And then 9 subtract 1 gives me 8 x's on the top. And then right here, if I'm just dealing with my y's, I would have 2 subtract negative 3. Oh, I'm out of room. So 2 subtract a negative 3 is on top. And then there is a chance, because those are pretty small, they might go 4, and they might probably for sure do 3 squared, so they'll put 9. So that is your final answer. And those are important problems. They're kind of long, but that's what you're likely to see on a test. So those, when you see them in your homework, practice them a few times. Good job, you guys.